So in the previous class, we saw application load balancer, and then we started off with a service called Route 53, right? Which is the DNS service on AWS. So we are going to continue with that, right? So in yesterday's class, we saw what is a domain, right? How do you purchase a domain, right? And then we saw basically what is a hosted zone, right? So today we'll be seeing, and then we saw what are DNS records. Okay. So today we'll continue with the DNS records and the most important thing, something called the routing policies, right? On Route 53, right? So in order to do this, we need a small environment, right? So what we are going to build is, right? To see it practically, right? So we are going to build two ELBs, right? So we'll have two load balancers in different locations, right? Maybe one we'll have in US East 1, right? And one we will have maybe in right? And we will put an instance behind each of these things, right? One or two instance doesn't matter. So just to see what are the routing policies. So we'll put one instance behind each of the load balancer, okay? And then we have our domain, right? My domain is called technoblog.com. I'll just put short form tnb.com. So I have my own domain technoblog.com, and we are going to try to access my website. Okay. Right. So we are going to access my hit my URL and see where it is going to go. Right. How we can do it on Route 53 with the DNS. Okay. So in order to do this, we need to create this environment first. Then we'll go to the routing policies, and then we will see. So let me open. I'm in US East 1, right? So I'll create two load balancers and just host my sample application on that, right? So let's go ahead. Let us launch our instance first in US East 1. Right, if you have any question, just ask, you can ask me, right? I'm just going to put myself on mute while I create this environment. First, in US East, I'm going to create one load balancer and one instance. Then in Mumbai, I'm going to create one ELB and one instance. And then we will come to Route 53 to see the routing policies. Okay. Okay, so we have created our environment, right? Over here, right? So we have created two uh, ELBs, right? With one instance we had, right? One in USA, one in Mumbai, right? And I have my domain called technoblog.com. Okay, I have my domain technoblog.com, and now when people access my website, where is their traffic going to go? That's what basically you can say maybe DNS is about, right? So first we will check whether our load balancers are working, right? So let me just straight away open the load balancer DNS URL, right? And then say when my application is working. Okay. So my thing is working, right? So what I'm going to do is in the US one, again I'm just going to go inside the US instance and just add a piece of information that it is coming from US so that it is easy for us to identify, right, from which server our traffic is coming, right? Because both we have posted the same website in two different locations. Right, so I'm logging into the US server. And here, let me just call this server. Right, for the India server, you will not see this text, right? So that it's easy for us to identify. Okay. So if I hit the US load balancer, right, you will see that it says USA server. For India, you will not see this thing, right? So that we know that from which server, from which location our traffic is being served, right? So basically, what is Route 53? It is DNS management on AWS, most basic feature, right? So we have a domain. For that, we have a hosted zone. That is actually the zone file where our DNS records are going to be there. And whenever you create a domain, these two DNS records are already there for you, and we usually don't modify these things. We saw this yesterday, right? So the first thing, what is DNS basically used for, right? Right? And remember, whenever you are creating a hosted zone, like I said, you can use DNS for both internal and public. That is both private and public hosted zone, right? So when you say create hosted zone for your domain, right? So you give your domain name, you give the description, and you have to specify whether it is public or private. Public means that is for traffic that is routed over the internet. Private means for inside the VPC, right? I'll come back to what is private, right? First, let us finish this public. But now, whatever I'm explaining, right, the routing policies, it is the same whether it is private or public. It does not matter, right? So in DNS, what are you basically going to do? Like I said, most basic thing is you are going to map a domain to a IP. So I have a domain technoblog.com. So all this while we were opening the DNS with its DNS name. Sorry, the DLP with its DNS name. So normally you are going to have your own domain name in a company, right? Your application, right? It might be hosted on an EC2 instance, or it might be hosted on a load balancer, right? So people are going to use the domain name. They are not going to use IP addresses much, right? So how you map your domain to your IP address is what is basically DNS going to do. Now, say for example, we have hosted our instance. Sorry, we have hosted our application on a EC2 instance without load balancer, right? So assume that we don't have this load balancer. We only have EC2 instance on which I have deployed my application, right? So how do you map it in root 53? So you go here and you say create record, right? So in the new console it is confusing, right? Even for me it is a little confusing in the new console, because in the old console everything was there in like a single screen where you could edit all these things, but no problem, right? Okay, they still have the old console. Okay, so we will see it in the old console and then you can map it to the new console, right? See, in the old console it is very simple. You can see it in one single screen. You don't have to click through many screens, right? It is the same stuff more or less, right? You go to hosted zones, right? You will see your domains. You click on your domain, right? You have the uh, you have your existing DNS records, right? And then you say now let us say you have your application hosted on your EC2 instance. I'm going to say create record set, and you see here in the same screen itself you get everything. New one, I don't know, 3-4 times you have to click to do the same thing. Right here you have all the values in one single place. Okay. Now what is our domain? Technoblog.com. So if you want, you can add whatever you want, right? You can add www. So remember that www is also a subdomain, right? You need to add a DNS record for this also, right? If you want people to open your application with both technoblog.com and www, you need to add a DNS record for this, right? Some browsers might automatically interpret it, but usually you should not assume that technoblog.com and www are the same, right? Suppose say now my domain is just technoblog.com. So I say I don't add anything over here, right? And an A record, what is an A record? It maps a domain name to an IP address. So here we are using a EC2 instance. So it has an IP address, public IP address. If you are using a public hosted zone, you need to use the public IP. So now I can say, don't worry about alias, we'll come to that, right? So I can say technoblog.com, right? The record is going to be an A record and it is pointing to my instance. Okay. So now when I say create, right? So when I create, right? So technoblog.com, right? Points to this IP. So when somebody opens technoblog.com, right? They will be routed to this IP. This is how your websites or DNS, this is how people configure it. People means who does this? The owner for technoblog.com, the domain owner who has access to the DNS, right? So here now if I go and say ping, you should see that IP. Usually it might take a few minutes for it to show up, right? As soon as you add your DNS record, it doesn't resolve, right? So here luckily for me it has, but sometimes it will not. It might take a few minutes. So don't think that just because you add DNS record immediately it will come, right? So how is it showing this IP? Because I added this value. So whenever you update your DNS record, it is what you say, it is propagated across the world, right? So your ISP will have a DNS server, all that stuff, right? So whenever you're making a request, how does it know to which IP to go? Depends on what the domain administrator has added. Okay, so don't worry about the reply. We are not getting a ping reply because on the instance we have not opened that security port. But you're able to see that it is going till the instance. Now, if I open my browser and say technoblog.com, what you will see? You will see the application open from the USA server because it is pointed to that. Right? It is pointed straight away to the instance. So it is going to hit this instance. So if I replace this instance, if this instance has a problem, right? If its IP address is going to change, then what I have to do is I have to go to root 53 and update it because the end user, he is going to remember this URL. He is not worried about the IP, right? So this application can be over a instance, it can be over a load balancer, right? It can be anywhere, right? So root 53 does not mean that it has to be only in AWS, right? Your server can be anywhere, right? It can be in Azure, it can be in Google, it can be on premises, it can be anywhere. This root 53 is like a address book where you map your domain names to IP addresses or the other DNS records that you have seen, right? So to use route 53, you don't have to use ELB instance. It can be any resource anywhere in the world. It has to be accessible over the internet, basically, right? It can be your own server on premises or pretty much anything that you have access, right? So this route 53 is just like the address book where you map your domains. So you don't like technoblog.com, say your domain is demo.technoblog.com, so you add demo. And then suppose it is on an instance, you say a record and you specify the value. Okay, here what is important is, right, so this thing, right, technoblog.com is called the naked or the zone apex, right? When you just use your domain name without any subdomain, it is called the zone apex or the naked domain, right? Just technoblog.com without any subdomain. This is called the zone apex. And always the zone apex should be an A record or a quadruple A record, right? Your zone apex should be a record or a quadruple A record. You cannot have CNAME or something like that, right? That is, your zone apex should always point to a IP address. That is the DNS rule, right? But other things, they can point to different stuff. Now say for example, so if I try to put something like CNAME is called alias. So maybe I'll show you an example of alias. Let me see, because these days some websites are blocking these type of requests. So now say for example I want to go to news.technoblog.com, right, and I can add an alias to this, to some, say some news website, right? Say I go to the hindu.com, right? So CNAME is usually another domain name, right? Here you see it says the domain name that you want to resolve to instead of the value in the name field, right? So for this you are giving an alias. So the word alias here, this meaning is different. We have not yet come to this alias, but CNAME is a type of DNS record which sometimes is also referred to as an alias, right? But CNAME alias and this alias are different. Okay, they are different, right? So CNAME, it basically points one domain to say another domain. So when I do something like this, right, so now when somebody tries to hit news.technoblog.com, it will go to the hindu.com. So when I go to right, you see it is going to the hindu.com. How is it going? Because I have added that DNS record. So if I say for example, right, so here again right, again this, like I said, some websites are not allowing us to do this type of thing, right? So I'm not using Cloudflare or anything. Hindu is using Cloudflare probably, right? So my request is actually going there. I know it is working because when I ping news.technoblog.com, it is going to the hindu.com or some other website we can put, right? Say for example, because all these NDTV, they are all blocking this type of routing, right? Say for example, let us see whether cnn.com will work, right? So whenever you update a DNS record, okay, and you ping, right, sometimes it will take again some time, right? For me it's happening much faster because I'm using a faster DNS service, right? But sometimes it will take a few minutes. So usually we should not update the DNS records during working hours in real time unless it is absolutely required, because whenever you update your DNS records, it might take a few minutes for these values to become uh, to take effect, because your browser might cache the old value, your ISP might cache the old value, right? So we will see just basic how the DNS is working. But here you see now when I say news.technoblog.com, it is going to cnn.com, right? Now here you see I'm getting a different error, right? So again, these people, they have blocked it at their security level so that people don't put something and come to their website, but it is possible, right? Like I said, your gmail.com, right? They will give you the DNS record. Suppose you're hosting your company's mail, right? For example, I said I have a domain called hellocloud.in, right? So I have added a DNS record where if I put mail.hellocloud.com, it goes to Gmail. How is it going? Because it is there in the DNS record. You can just say gsuite DNS records for email. So they will give you what DNS records to add if you want to route your mail dot whatever to some domain, right? So let us take some basic website, some news website. I'm just trying to show you that. Let us take some local news. I'll take this basically. These guys might not have much security. Okay, let us take this URL. All right, so let me add this in the DNS record here. So please don't add HTTP and all that. That should not be there in your DNS record. Just your domain name. So now if I ping, it should resolve to see. Now you see it is still resolving to CNN. Again, like I said, it will take a few minutes, right? Because of the DNS cache. Right, you see it is still going to CNN. It has to resolve to the new thing which I put, right? So it is going to take some time. While that is happening, we'll quickly see how this DNS is actually working in the background. Whenever you make a request, what is actually happening in the background, right? This is not for exam, just for practical point of view, right? So let me just put a diagram over here. Right, I hope this is clear. Right, so what is basically happening in the background whenever you make a request for some domain, right? So we start off from here, from step number 1, right? So you are the user, right? You are making a request for something. So where is this request actually going? It goes to something called the DNS resolver, which is usually your ISP, right? They will have their own DNS server, right, which answers these queries, right? So you are saying I want to go to example.com, so your query goes to your ISP. Then what your ISP will say, right, it will go to something called the DNS root name server. So this thing called the DNS root name server and the name server for .com TLD, these are hosted by certain companies. There are a few DNS servers across the world which manage the DNS infrastructure, right? So whenever you say I want to go to example.com, right? So what is our work is to, for example, this example.com domain owner's duty is to update the record over here. So he is going to say example.com is pointing to some server IP or some load balancer. So how does the user he get this answer? How does the user get this answer? So whenever he makes a request, it will go to your ISP, right? Your ISP will see whether it has that value in the cache. So you will say, okay, I don't have it in the cache because the first time somebody is accessing this website. So it will go to the something called the DNS root name server, right? These are the name servers which are there, I think 4 or 5 across the world, right? Managed by certain big companies, right? So this DNS root name server, the first request goes to the DNS root name server. The DNS root name server will say, you go to the name server for .com TLD. So again, all these are called TLDs. I told you .com, .net, .in, all these are called TLDs, top level domains. So these top level domains will have their own name servers. Again, these are global. You don't manage these things, right? All this is managed by ICANN, IANA, those guys, right? So basically, it is like somebody is coming to, some courier guy is coming to your house to deliver, right? So what he will do, suppose he is not aware of the area or whatever, he'll come close by, he will ask somebody, where is this street? Then somebody will show him where that street is. Then he will come into the street. Then he will ask somebody, where is the apartment? Then he will come to the apartment. He'll ask the watchman, which apartment, right? Something like that is happening here, right? So the DNS root name server will say, you go to the name server for .com TLD. I don't have the answer for this. You go and ask the name server for .com TLD. So your what do you say, ISP, from there again it will go to this name server for .com TLD. So this name server for .com TLD will say, go to the root 53 name server. So whenever you add your DNS record, what is happening is these changes are going to be propagated automatically, which is why it is going to take some time, right? I already added my record, but it is still pointing to the old one because these changes have to propagate. It will take a few minutes. Sometimes your ISP might still cache the old value, right? So whenever you do this, right, you might have to refresh your cache, or you have to wait for the cache to expire, right? So it is not enough if you just update or change the value or add a value over here. It's going to take a few minutes for it to propagate. So whenever you add your DNS records here, this name server for .com TLD will know that you have added this, which is why it says you go to root 53 name server. It will say, I also don't have the answer, but I know where you can find the answer. You can find the answer in root 53 name server. This user is using root 53. Instead of root 53, if you're using some other provider, it will say you go to that provider. That is the provider where you have added your DNS record. So the request will come here. Then in root 53, you have added the answer. You are saying example.com is pointing to 1.1.1. So it will return the IP, and your ISP will return the IP to you, and your machine, it goes to that IP and it gets the answer. So once this happens, the next time you access, probably your ISP is caching that value, right? So now it does not have to do all these other steps. It knows, okay, already somebody has gone to example.com. I have the answer for that, right? I have the answer for that. So it will immediately give you that answer, which is what is happening from its cache. I'm still getting the old value, right? So once that cache expires, it might be there for a few minutes or whatever, right? So again, it will do these steps. So these steps happen in a fraction of a second, right? No, fraction of a second. So this is what is happening in the background. How is your browser able to find the server? Because in the background, all these steps happen. So if DNS is broken, right, if there is a DNS problem, you will not be able to access the website. The website might be working, but this translation mechanism, if it is broken, then the internet will be broken, right? So you have to open with the IP address, and again, all servers might not have a fixed IP, right? So if I put it behind a load balancer, then we don't know what is the IP. It might change, right? So DNS is like the backbone of the internet if people want to access stuff over the internet, right? So this is what basically is happening uh, at the backend, right? So what we are managing is this root 53, not the name server. Name server is provided by Amazon. We are just adding our records which are stored in these name servers, right? We saw yesterday what are the name servers, right? So AWS provides you 4 name servers which are located around the world for high availability. Even if one name server goes down, some other name server will answer. The name server is what is giving these answers to whoever makes a request. It will say, here I have this answer, you go to this, right? Okay, right. So now we have added this. So let me go ahead and ping and see whether it is coming to this, right? Now you see it has updated, right, to the new domain. It will take a few minutes. So how long? Suppose you want your DNS resolution to be faster. What you can do is you can bring this TTL value down. All right. So what is TTL? It tries to specify how long this record has to be cached. Right? How long this record has to be. I'm giving a short value, which is why my DNS is updating a little bit faster. So don't think in 1 minute it will update. This is just what you are specifying. If your ISP or your browser is caching it for a longer time, right, it might take a few more seconds or few more minutes for it to update. But TTL is like you're specifying how long these values have to be cached. So remember, whenever you make an update over here, it is pushed out. So how frequently do you want to, what do you say, publish this value? Something like that. TTL. Okay. Now let us see whether it opens this news website at least here. Right? Sorry, I should have opened technoblog.com. Right. News dot. Right. So again, this is because of my DNS. Right. Some DNS providers are not allowing this to happen because I'm using Cloudflare DNS. Just give me a minute. Let me see if I can change this out. Okay, so in case the class gets disconnected, just hold on. Just for a fraction of a second, it might go down. So it will reconnect. Yeah, are you guys able to hear me? Okay. Yeah, are you guys able to hear me, guys?
Yeah.
Okay.
Yes.
Okay. So I just updated my DNS, but my browser seems to be caching this value. So in the DNS class, it's going to be like this only. We just have to wait. Right. I'm just trying to. Right. Right. Actually, it should go to that domain thing, but for some reason, it's not going because of my CNAME. Right. So basically, think of CNAME as you're mapping one domain to another domain. Right. So this again, they are not allowing this type of to third-party redirects. I think these days, right? You requested a web website. I think it is my browser. Let me open it in Firefox and see. Oh, it is still it's going to take some time probably. Okay, so we saw what is a record and what is canonical name, right? So main thing what we need to notice whether it is resolving or no, right? So it is when I put some domain, it is going to the other domain. This is the CNAME, right? And what we have been using is called the simple routing policy. Simple routing policy is like one-to-one mapping, right? So this is the first thing that we are going to see, right? First routing policy is called simple routing policy, right? The record can be anything, but what is the routing policy? We said simple routing policy. So what is simple routing policy? It is your mapping one-to-one. That is, whenever somebody is opening technoblog.com, their answer is going to go to one server or one ELB or to one resource, right? So now I said technoblog.com, right? I created a record set, right? I pointed it to my EC2 instance, right? Or I pointed news.technoblog.com to some news website. So it is like a one-to-one mapping. So anybody who opens technoblog.com, it will go to this. Anyone who opens news.technoblog.com, it will go to news. Something, right? So it is one-to-one. It is straightforward. So all DNS providers, they provide this, which is the default one-to-one mapping. So what I did was, instead of EC2 ELB, I pointed to straight away to the instance. But real time, right? So when you're using AWS and ELB, you are not going to point to your instances, because you might have 3 instances, 4 instances, 5 instances right behind ELB, right? So how do you point it? So now what you need to do is you need to point your technoblog.com to your ELB. So we have posted our application on both the locations, right? We have hosted our application on both locations. So now instead of using the instance's IP address, I'm going to use the ELB. So whenever somebody opens my domain, I want the traffic to hit my US ELB. We'll come back to Mumbai. Okay, so we are talking about the simple routing policy where it is a one-to-one mapping. Okay, so here we'll go back. I'll remove this, right? So I'm just going to say technoblog.com. So here if you try to give a CNAME, it will give an error, because the zone apex, right, it has to be a IP address. It has to be either an IPv4 or a IPv6. You cannot have a CNAME for a zone apex. Okay, so it has to be a record or a quadruple A, right? So now what I want to do is I want to point my technoblog.com to my ELB. My application is hosted on the ELB. I don't want to hit the instance directly, because tomorrow this instance might not be there. I might replace it with one more instance, or I might have 3 instances behind the load balancer. Then how do you map it? So you have to map technoblog.com to the ELB. So you have to put what? The ELB's IP. Because you are doing it for the zone apex, it has to be a record. If you put anything else, you will get an error, right? So, but we don't have IP for the ELB. I told you, never try to find the IP for the ELB, right? That warning is given here, right? Because the IP address associated with your load balancer will change over time. So you should not, to ping the load balancer, get the IP and put it. That is not the correct way. So if you want to create a record, right, and a record has to be IP, and ELB does not have IP. So how do you do that? So to do that, AWS has provided a feature called alias. It is similar to CNAME, but it is not the same as CNAME, right? It is AWS's implementation, right? So alias usually points to some AWS resource. These are the supported AWS resource. That is your static S3 website, right? We saw static website hosting. So if you wanted to use your own domain name, you can come here and you can map it by using something called alias. This is AWS's implementation. It is similar to CNAME, but it is not CNAME. CNAME, all these are global standards, standard DNS records, right? So AWS has something called alias, right, which points to another AWS resource. Here you cannot put whatever you want. It has to be one of these 6 or 7 types, right? That is a static website hosting, or application load balancer, or classic load balancer, or the network load balancer, or the CloudFront, right? So in the beginning class we saw CloudFront distribution, right, where you get your URL, right? So it can be one of these things, right? All these are AWS resources. So here we are using what? A load balancer, right? Which load balancer are we want to point? We want to point to the US load balancer. So you will see both your load balancers here. If you don't see it here, you can just copy the DNS name from here and put it over here. It is the same. You can copy this name and put it over here. Sometimes it will take a few minutes for this to pop up, right? So here I can map like this, right? But if I don't put alias and I put the this name, right, it will give error. If I copy this and I put this over here, right, it will give error. It will say zone apex has to be a record and a record has to be IP address. And our load balancer does not have an IP. So you use alias, right? So this is AWS implementation where you want to use uh, a domain name instead of an IP address, right? For CNAME also you will see alias, right? So alias has another use, right? We will see what is that also. What is the advantage of using alias? It is not only for canonical name also you can use, for certain other records type also you can use, but basically an alias is one of these targets, right? It can be a CloudFront, S3 static website, ELB, uh, application load balancer, the network load balancer, right? These are all AWS resources, right? And the routing policy is simple. So we are talking about the routing policy. Don't worry about this health check. We'll come back to the health check, right? So I'm saying save records. So now anybody who goes to technoblog.com, their traffic will be routed to the ELB. Now if I go and ping over here, right, it should go to the ELB. I'm not using news dot, I'm just saying technoblog.com. Right, now you see it is showing a different IP. What is this IP? This is probably my present IP, one of the IP of my load balancer. Right, now if I open my domain, right, it has to open the server, the US one. It is hitting the US ELB, right? Because I have pointed it to the US ELB, right? If you don't want the US ELB, you can point it to the India ELB, right? According to our example. So this is called simple routing policy, where you're mapping your domain name or subdomain, whatever. It can be anything. It does not have to be techno. You can say news.technoblog.com goes to the ELB, whatever is your domain, you are pointing it to your ELB. That is one-to-one, simple routing. Okay. Let me know if you have any questions in this simple routing policy. Right. So all DNS providers by default, it is simple routing. Okay. That is the default routing policy. Right. All right. So we'll go and we'll remove this. We'll delete this record set. So always please remove and again recreate, because sometimes when you update it will not, it might cause problems. So let us remove this, right? So if I remove this now, if people hit technoblog.com, it will not go anywhere. It will say DNS error, right? Unless your browser or something is caching it, right? It will say, sorry, I cannot find technoblog.com, because we have removed that DNS record. Okay. So if you get this error, it means DNS has not yet resolved, or there is no record for it. It does not know where to find it because we have not added it. Okay. The next thing that we are going to see is called the weighted routing policy. Right. Next thing is weighted routing policy. Right. So what is weighted routing policy is, say now you can have multiple records for the same domain name. Say now I have technoblog.com. I want to point it to both my US and Mumbai. So how can I do this? Right. So the first type is called weighted routing policy. Weighted routing policy is basically you can specify some weight for each value. Right. Suppose I can say USA has a weight of say 1, and this Mumbai has a weight of 2. Right. You can give any whole number. You can give 1, 2, 100, 200, right? 15, 20. You can give any number. So what is this weight? We call this as the weight. We call this value as a weight. You assign a weight. So you create two DNS records. You say technoblog.com is pointing to USA with a weight of 1, and you say technoblog.com is pointing to India ELB with a weight of 2. So what is the meaning of this? So whenever somebody makes a request, right, where is the request going to go? Is it going to go to US or is it going to go to Mumbai? So for the weighted routed policy, how it is going to identify is, so whenever you're making a request, right, it hits route 53, right? You have route 53 over here, right? So whenever somebody is saying technoblog.com, finally it reaches route 53, and route 53 will decide where to send the query. Based on what? Based on the record that you have added over here. So here we don't have any record, so it is saying it does not know where to go, right? So once you add the,
Siddharth, sorry to interrupt you.
yeah, go ahead.
So one question here. So even in like CloudFront, we have this option called geo this thing, right? So you can also route according to the location, right?
No, CloudFront it does not route. CloudFront is just says whether you can access or no. Routing is done only with DNS, not with CloudFront.
Okay.
CloudFront is, if the request is coming from India, it will not allow. Suppose you are pointing to CloudFront here instead of ELB, when you say create record set, and you're pointing to CloudFront URL. Here you see CloudFront will be there. Where is that? Here, right? So suppose it is pointing to some CloudFront URL, right?
Okay.
So here you do that. Suppose when you map it to CloudFront URL, so whenever a user is making a request to this, it will go to the CloudFront URL. So there, if it is coming from India, there CloudFront will block it, right? DNS will not block it, right? For this we have separate, right? If you want to block, that is separate. So CloudFront, the blacklist, whitelist is different from this, right? There CloudFront, it decides whether to allow or no, not DNS, right?
Okay. Got it.
Okay, CloudFront, it does not do any DNS routing or anything. That routing is handled over here. So here is where you can put your ELB or you can put your CloudFront. Then CloudFront, if it has any filtering, there it will filter. Okay. So here I'm going to create a record set, 2 record sets, right, with different weight or same weight, whatever. It's a number. So whenever somebody is making a request, it hits route 53. So where is route 53 going to send the traffic now? So don't think that it is just one request that is coming. There are going to be in real time hundreds of requests that are coming for the domain, right? So when the requests are coming, where is it going to forward the traffic? Now you have given 2 values for the same thing. So where is it going to go? So if you choose the routing policy as weighted routing policy, you give a weight. And how does route 53 calculate where it has to send the DNS query? Should it go to US or in Mumbai? It depends upon the weight. How it is calculated is the probability of the traffic going to USA is going to be calculated as the weight of USA divided by the total weight of all the records. That is 1 divided by 1 plus 2. That is equal to 1 by 3. Here it is going to be 2 divided by 1 plus 2. That is 2 by 3. So 1/3 of the traffic will go to USA, 2/3 of the traffic will go to Mumbai. So if there are 100 requests which are coming, say 33 requests will go here, 66 requests will come here. So the weighted routing policy, right, how it is calculated is based on the weight. So if traffic is coming, how much traffic should go here, how much traffic should go here, right? So here you can give any number. It does not have to be 1, 2. You can give whole number, any whole number. It can be above 100, right? The calculation is performed like this. Now say for example, I give a number like, say I give a number like 40 and 20. So how is the weight calculated, or what is the probability? How much of traffic will come to US and Mumbai, right? For USA, you will get 40 divided by 40 plus 20. What is this? 40 by 60, which is again whatever 2 by 3, right? Same thing here, it is 20 divided by 60, that is 1 by 3, right? Or you can give a value like 80-20 also. If you want to keep your calculation easy, you can say 80-20. 80-20 is automatically 80% traffic will go here, 20% traffic will go here. If you want to calculate and see, you can still calculate and see. It will be 80 divided by 80 by 20, 100. That is 80. Here it is going to be 20 divided by 100. That is 20%. Right? Right? Or if you want to do in the mathematical way, here it is going to be 1/5 of the traffic. Here it is going to be 4/5 of the traffic. Right? Here it is going to be 1/5 of the traffic and 4/5 of the traffic. Same thing. Right? So you can specify it as a percentage. So it will always add up to 100%. Right? Any whole number you put, it will always add up to 100, or it will add up to 1, you can say. Right? So any number you want, you can put. Right? I can put 6 and 7. Then what is the meaning? You get 6 by 6 plus 7. Here you get 7 by 7 plus 6, 13. If you add both these values, you get 1 or 100%. Right? Any number you put, it is going to add up to 1. Right? The total combined weight. So how much percentage of traffic has to go where, you specify based on the weight. Right? So where this is useful, say you want to send certain percentage of traffic here. Maybe you're doing something like you're deploying a new version of your application. You don't want everybody to hit the new one. You want a few users to go to a particular location, right, to see whether the features are working. You want to get some feedback, right? You can use something like this, right? Weighted routing policy. So we will see how to do that. So we have 2 load balancers. So how do you do that? You go to route 53, you say create record set, you give your domain name. We will just use the zone apex, right? And you can say we are using an ELB, so just keep it at a record and use alias, right? Because zone apex has to be a record. If you are putting for any other CNAME, sorry, any other subdomain, you can use CNAME, right? You cannot use a record for a like you cannot give a domain name here, it will give error, right? So here you can use a CNAME. So don't worry about MX records, TXT. These are used for special purposes, right? Right? So we are going to say a record for technoblog.com because we are using an ELB. It does not have an IP. So I say alias, and now I'm going to enter the alias. So first I will enter, say Mumbai, right? And here I'm going to say routing policy is not simple. Now it is weighted. And here you have to give the weight. That is any number you want, you can give. Now say for example, for US I want to send say 30% of the traffic and 70% of the traffic I want to go to Mumbai. So I can say something like 30 and 70 to keep our calculation easier, right? So I will say for Mumbai I'm giving the weight of 30, and here you can give some description, right? I will just call this Mumbai. Some description you can give. This does not matter, right? And don't worry about the health for now. We'll come back to this, right? So I'm saying technoblog.com is pointing to India, and the routing policy is weighted, right? So I'm going to create another record set, right? Same thing. Now I'm going to point to the US, and I'm going to say weighted, and then for this I'm going to give a weight of say 70. I'll just call this India. Great. So for the same thing, now for technoblog.com we have 2 records, right? So now when a DNS record is coming, so when a DNS request is coming, when somebody opens my site, it hits route 53, and route 53 will decide where to send the traffic. So now because we are using a weighted routing policy, it will route based on the weight. So because we have given 30 and 70, so it is not like for every 3 requests or for every 7 requests 1 request will go here. It is not like that, right? Suppose you are getting 100 DNS queries, right? People are opening your website, right? So everything is a DNS query. Every time somebody hits technoblog.com, it's a DNS query, right? So it is not like first the 70 request will go here, then the next 30 request will go here. It is not like that, right? So at the end of the day, the average will be like this. So don't think that if 100 requests are coming, first 70 will go here, next 30 will go here, or it will alternate. If you give say 50-50, it is not like one request will go here, one request will go here. No. At the end of the day, the average will be 70 and 30. Right? So you might get hundreds of requests every day. So maybe first few requests will go here, then it will go here, then it will continue to go here for some time, then it will come here. Right? So end of the day, the average will be this, in this ratio. Right? So some people assume that if we give 70 and 30, so if 100 requests are coming, so first 7 will go here, then 3 will go here, then again 7 will go here, then again 3 requests will go here. No, it is not like that. Right? So if 100 requests are coming, maybe the first 40 might go here, then 20 might go here, then whatever. So that is handled by route 53. End of the day, it will maintain this ratio. Right? So now if I go to technoblog.com, right? So you can also try to open the website, right? So for me, you see, now it is going to the US server. I'm refreshing the page, right? It is still going to the US server, right? So if I ping also, right, it will show me some IP, right? You see the IP is different now. This is not my instance IP. 35154 is not my instance IP. It is my ELB's IP, right? And ELB does not have a fixed IP, which is why every time you ping, you will see a different IP. So we should not use IP for the ELB. So we have mapped our ELB, right? So now you see for me the request is coming from US. Can somebody try to open and see whether you are getting from India? So what is the weight for our US? We have given 30, right? India 70. So but you see I'm opening, I'm still getting US. I made many requests. I'm doing refresh, control shift or hard refresh, right? So for some time it will come from US, then it will switch to India, right? So maybe can one of you guys try to open? Now you see it is coming from India, right? You see that US thing has disappeared, right? So it will, what do you say? It will try to maintain this weight that you have set, this ratio. So 30 and 70 means 30% traffic goes to US, 70% goes to Mumbai. So at the end of the day, it will be like this, right? So while I am getting the India site, you might get the US site, right? So in real time, when a lot of people are accessing, few people will be getting the, what do you say, the India, few people might be getting the US, right? Is this clear? So this is called the weighted routing policy. So you can have 2, 3, you can have how many ever you want, right? We are doing it with 2. Okay, so you can add your weight, right? 3, 4, whatever. Accordingly, it will calculate the weight. So it can be a ELB, it can be instance, it can be anything, right? We are using an ELB here, right? If you don't have ELB, you can put your instance also. You can map it to an IP address and say, use the weighted routing policy. Okay, so here I am using ELB so that we can see all the features. We can see what is an alias, what is an, already in the beginning I showed you IP address, right? So you can map your domain name to ELB or to IP, that is up to you, right? So we are using ELB, so we are mapping it to the domain name. If you don't have a ELB, you don't have to use alias. You can just straight away put the instances IP and use the routing policy as weighted. It is still going to work, right? Instead of hitting the ELB, it will straight away hit the instance, right? So this is called the weighted routing policy, where your request is routed based on the weight that you specify. Okay, so we'll go ahead, we will remove these record sets and we'll go to the next one, right? The next routing policy is called latency based routing policy, right? So what is this latency based routing policy? Again, we have our same stuff. We have our USA ELB and we have our India ELB, right? We have route 53 here handling our DNS record, right? And we are making a request for technoblog.com, right? Now we are going to use latency based routing policy. What is latency based routing policy? So again, say I'm going to create two values for technoblog.com, right? One pointing to US, one pointing to India. But now I'm going to say it is going to be based on latency, not on weight. So what is latency based? So there will be a lot of users say accessing your application, right? So you might come from Bangalore, right? I'm coming from Hyderabad, right? Somebody else might be accessing it from USA, right? People from different parts of the world or people located in different parts of the world are going to say access your website. So all their queries will go to route 53, right? And now I'm saying for technoblog.com, here I'm adding a record. I'm saying technoblog.com is based on latency, right? So what is latency based routing policy is, right? So it does not depend upon the user's location. For that we have a different policy. What this latency based is doing is whenever a DNS request comes to route 53, it is going to see which will be faster for the user. Will it be faster if it goes to US? Will the latency be lower if it goes to US, or will it be lower if it goes to India? Indirectly it depends upon where the user is, but it is not what do you say, it is wrong to say that it depends on where the user is, right? So route 53 will decide where to set depending on where it thinks or where it calculates the latency at regular intervals. Okay, so if a request is coming from Bangalore, right, so route 53 will see, will it be faster if it goes to India or will it be faster if it goes to US? Most of the time it will be faster if it goes to India because it is closer to this user. The latency will usually be lower for locations which are closer to this user. If a user from USA is coming, his request will probably go to USA because the latency will probably be lower usually, unless this location is having some problem. If the network connectivity is slow or there is some problem, then a USA user's request might come to India also. Now say we have a user from Australia. So where will his request go? So it is not based on this user's actual location because we don't have any Australia here. But still, if a user from Australia is accessing, route 53 will decide. So this guy is coming from Australia, which will be faster? Will India be faster? Is the latency lower if it goes to India, or is the latency lower if it goes to US? Or if some user is coming from the Middle East, where will his request go? Everything hits route 53. We have only US and India locations, right? So it will see, okay, this guy is coming from Middle East. So will US be faster or India be faster? Sometimes it could be India, sometimes it could be US, right? Because he's in the middle, right? So it depends upon purely the latency that route 53 decides. That it calculates the latency and it sees which is going to be faster. Based on that it routes. It does not depend upon the user's location because the user can be from any part of the world. Your servers or your resources can be in any part of the world, right? So route 53 it decides. You don't say if user is coming from US, go to US, right? It can go to India also. If this US is having high latency, some network issues, then a guy coming from US, his traffic will also go to India, right? So we will do this and see, right? So I'm going to say technoblog.com, again a record alias. I'm going to point first one to India and I'm going to say latency based routing policy, right? And where is my India thing located? It is in AP South 1. Okay, the region is AP South 1. Some ID you can do. Again, here I'll just call it India. Okay, and I'm saying create. Right, I'm creating another record set. Same thing, alias. Right, I'm going to point to my sorry USELB, and I'm going to say latency based. And here, what is the region where this is located? It is in US East 1. Okay, and here I'm just going to call it USA, and I'm going to say create. So what do we have now? We have two answers for the same thing, right? And we have the region, right? What is Mumbai is AP South 1, and then you have US, and then we are calling it based on the latency based uh, routing value, right? The routing policy is latency based, right? Now, how is this going to work, right? Now, how is this going to work? Now, say for example, if I ping, now I am coming from India, right? So now, if I open my domain, it should go to the India website. I mean, it will go because I know the latency will be lower unless there is some issue, right? Now, how can I simulate traffic from some other country, right? So if you want to practice this, you can install a free VPN, right? So that you can install this free VPN, right? So that you can simulate traffic like it is coming from US, right? So you can install some free VPN software like this, right? So say for example, now I'm going to connect to Australia. That is, I'm going to my traffic is going to pretend to be coming from Australia. Okay, so the meeting will get will go out for a couple of seconds. Just hold on when I connect to the VPN. Okay. Okay. So is my audio clear to you guys?
Yes, yes.
Okay. So for example, now I'm in Australia. If I want, I can check my IP. Right. So this is an IP from Australia. Right. Or you can go to what is my IP or whatever. Right. I'm sure I'm connected to the VPN. So now my traffic is going to pretend to come from Australia. Right. It is coming from Australia. Okay. So now if I open this, where is my traffic going to go? Right. So it depends on route 53. You see, it is still either it is coming from my browser cache, or maybe it decides that it is faster if it goes to India. Right. So maybe I will open over here Firefox. Maybe it might be cache. So again, DNS you just have to try, because I'm just a single user. I have to try multiple times. Right. So here you see it is still going to India, because it decides that for traffic coming from Australia, the India location seems to be faster. That is, the latency is lower, right? So it will go here only. You will not see US, because it decides that India is faster, so it is sending traffic to the India ELB. Now, if I go and change my location again, so now let me connect to, say, for example, we'll connect to, say, Mexico. Okay, again, the connection might go out for a few seconds. Just hold on. Okay, so now we are connected to Mexico. Okay, so now my traffic is going to appear to come from Mexico. Now if I refresh, right, you see it is going to US, right? So now why is it going to US? Because Route 53 thinks for traffic coming from Mexico, the US location will be faster because it is close by, right? Ideally it will be faster, but there is no rule that every time traffic from Mexico will go to USA. If there is a higher latency, some network issues, right? So it might go to India also. So it does not depend upon the user's location directly. Indirectly, mostly the closest location will serve the traffic, right? But it is purely dependent on latency, not the locations. For locations, we have a different routing policy. Okay. So again, I'm going to close the VPN connection. Just hold on. Okay. So now we are back to India. Now you see again, now it is serving content from India. So this is latency based routing policy. It is purely based on the latency, not the location, right? It does not depend upon the user's location directly, right? For that we have a different routing policy. Okay, so let me clean up this and we'll go to the next routing policy. The next routing policy is called, we'll go to geolocation, then we'll come to the failover, right? So geolocation is a routing policy which is based on the location, not the latency based. They might look similar, but they are different, right? So if you want to route the request based on the user's location, then you use the geolocation routing policy, right? So again, same concept, right? We have two, you can have two, three, it does not matter, right? So we have, sorry, we have our India location, we have our USA location, right? We have our domain, right? So the request is going to come to route 53, right? When somebody is opening this, right? Now we are going to use geolocation based routing policy. So what this is going to do, it is based on the user's location. User means the from where the request is coming, right? Say now we are in India, right? Say somebody is in USA, somebody is in Australia. Let us take maybe these three countries. So you can say if traffic is coming from India, you go to the India website. If the traffic is coming from India, if the traffic is coming from USA, right? If the traffic is coming from USA, you go to USA. If the traffic is coming from Australia, you go to India. It does not have to match same. You can do other way around also. That is up to you. You can map however you want, right? So here I can say if traffic is coming from India, you go to India. Or I can also say you go to USA. That is up to you, right? If the traffic is coming from, you go to, the traffic is coming from USA, you go to USA. If the traffic is coming from Australia, you go to India. This you can specify. You can map it however you want. It does not have to be India to India or USA to USA, right? You don't need to have location for Australia. You can say if traffic is coming from Australia, go to India. If traffic is coming from Middle East, go to India, right? If traffic is coming from Mexico, go to USA. So you can specify this mapping, right, in geolocation. In latency based, you don't do this. Latency based, route 53, it decides where to send depending upon the latency, right? So in geolocation, you can control where to send the traffic, right? Another important thing is here is if you don't specify where to send the traffic, the user will not get any answer, right? So for example, now say we have these three. So say we have people from different countries accessing, and I have created only two records. I'm saying if people from India, if the traffic is coming from India, you go to USA. If the traffic is coming from USA, go to India. India means just where my resource is there. Basically, I'm saying USA ELB or India ELB, right? I'm saying if traffic is coming from India, you go to USA. Okay, I'm adding only these two in my DNS. In route 53 record set, I'm adding only these two. Now, say now, what happens if a user comes from Australia? Where will his record go? Right? I'm saying if he comes from India, you go to US. If the request is coming from USA, you send the traffic to India load balancer. But now I have not specified anything for Australia. So where will the traffic go? Right? So if the traffic is coming from Australia, it will not go anywhere. He will get error. He will get a DNS error. Because you have to explicitly specify that. So for that, they have something called default. Right? Default means if it is not matching any of these conditions, then where do you want to send it? Right? It is recommended to add a default record set for this, because if you don't add it, if it does not match any of these conditions, then the user will get DNS error. It will say page not, you will get a DNS error in the browser. I'll show you that, right? Or you can say if it does not match any of these things, then all other traffic has to go to India or it can go to USA, or you can simply create a static S3 page and say, sorry, you are not allowed to access this content, right? A static S3 website page where you can send all other requests to this, right? It is indirectly a type of blocking, right? It is indirectly some type of blocking, but it is not like CloudFront, right? In CloudFront, you can specify the whitelist and the blacklist. Okay, so just hold on, guys, for a minute. Yeah, okay. So this default is like if it is not matching any condition, that to set. It is not compulsory, but it is recommended to add this. So we'll go and see how to do this geolocation. Okay. So you go into the routing policies again, right? Same stuff, right? So now I'm going to say technoblog.com is pointing to this India location, right? And I'm going to say geolocation, right? So I'm going to choose the location. What are the locations you can choose? It is predetermined, right? So AWS has this, right? They have continents, they have like country, right? You can choose from this list. You cannot put Hyderabad, Bangalore like that, right? So just whatever they have. Usually it is continents and countries, right? Okay. So now I can say, for example, if traffic is coming from India, then you send the traffic to India, or the other way around also you can do. It does not have to be same, right? Here you can put USA also, right? It will be there as United States, right? So you can say like this also, right? For some places you can choose the state also, right? For US, for example, you can choose further, you can drill down to the states also, but in India you can't do that, right? It is just what is there, right? You cannot choose the sublocation for India. It is optional for US, right? In India you can't do that, right? You cannot choose the state, right? These locations are fixed by AWS. At present they don't have, right? So I can say any traffic which is coming from India, please you send to the India load balancer. I will just add a some description over here. I will say India to India, something like this, and I will say create, right? And I'm going to create another record set, and I'm going to say same thing alias. Now I'm going to point it to my US, and I'm going to say routing policy is geolocation, and I'm going to say if the request here location is from where the request is coming. So I'm going to say if the request is coming from the United States, please send it to the US ELB. I'm not putting any state. If you want, you can do that. I'm going to just call this US to US, and I'm going to say create. Okay, so we have two records, right, based on the location, right? If the user is coming from India, then it goes to India. If the user is coming from US, then the request goes to US. Now we will see whether that is working, right? So now I am coming from India, right? You see, I will always get only the India website. I will never get the US website. Now it is purely based on location. Now if I connect to a US location on my VPN, okay, so what is that? Yeah. Okay, so just hold on while I connect to the VPN. Okay, so now I'm in the US location, right? So now if I open the website, I should go to the US server. You see, it is going to the US server, right? Because the traffic is coming from US, it is going to the US server, right? Now, if I go to some other location, not India or US, say I'm going to Australia now or Japan. Okay, so again, just hang on. Okay, so now we are connected to Japan. Okay, so now if I open my website, right, I will just open in a new tab here because the page is open, but you see still it is waiting. If I open in a new tab, probably it will be clearer. Now from Japan, the traffic is coming. My internet is working, right? Yeah, you guys can hear me, right? Yeah, my internet is working. Okay, but you see here it is giving error. What is it giving? DNS error, right? Saying address is incorrect because it is not able to find the answer. Why it is not able to find the answer? Because we have not specified. I am saying only if the request is coming from India, you go to India. If it is coming from US, go to US. This is the mapping that I have given. So it is going. If it is coming from anywhere else, if it is coming from Japan or Australia or anywhere, it will not go anywhere. User will get a DNS error, server not found. So if you don't want the user to see this error, you can add a default for the geolocation, right? You can create another record set, right? You can create alias, right? And you can say, what do you say? Geolocation, right? And here you can add something. You can add a S3 static website, or you can put India also. That is up to you. And you can configure the location as default, right? Default means, right? So it responds to queries from what do you say? Sorry, right? So when you say default, if it is not going to match India or US, then everything else will go to what you specify here. Okay, everything else will go to whatever you specify here. You can specify a static website hosting or some other server or whatever you want, right? That is default. If it is not matching either of the conditions, then you want to have a default. Ideally, AWS recommends you have a default location, right? I will just call this default some name, right? And I'm saying create, right? So here, what is it saying? If traffic is coming from India, you go to India. If traffic is coming from US, go to US. If traffic is coming from everywhere else, you go to India. Now we are still in Japan, I believe. Now if I try to open my website, it should go to the India location. Again, whenever if you are practicing this Route 53, you just have to wait for a few minutes. Immediately it might not take effect. Usually your browser is going to cache and all that stuff, right? So you just have to wait for a couple of minutes and try again. Don't just try once and say it is not working, right? Now you see it is coming from India, right? We are still connected to Japan, right? So it should go to India, right? Still it is getting DNS error. Probably it picked up from my browser cache. So we just have to wait for a few minutes for this to take effect. Assuming my DNS has been updated. Okay, so we have this default also, which is pointing to India. So now in a few minutes, you should see traffic here going to India from Japan. Probably it is taking more time to resolve from Japan, right? So this is not a problem with configuration. This is just DNS. DNS resolution is going to take some time to complete. Right here you see It has not yet got the answer, right? So probably if I try from Australia, it might DNS might be faster, or let us go from Italy. Okay, so now we are connected to Italy. So let us see whether from Italy it is working. Yeah. Now see, from Italy it is going to India because it does not match any of the conditions that we specified, right? So traffic is not coming from India or US, it is coming from somewhere else. So it will go to India, or you can send it anywhere else that you want. So remember, all these resources, right? They can be anywhere. They can be in AWS, they can be Azure, they can be anywhere. This value can be anywhere because we are doing everything in AWS. We are using all AWS stuff, right? The routing policy is what is the one of the main feature of Route 53, right? Your these values can be anywhere. They don't have to be in AWS. Okay, you can use the routing policy with any, what do you say, any server. It can be on premises or anywhere. You can do the routing like this. Okay, so this is geolocation. It is purely based on the user's location. Okay, so let me close the VPN again. Yeah, so we are back in India, right? So it opens the India website, right? So this is geolocation based on the user's location, right? So if you want to actively block users, then you use something like CloudFront or those type of things. Here it is like an indirect way of blocking. Here you don't say block. If you don't specify, it is blocked automatically, right? Okay, so we will remove these records, right? The next one that we are going to see is failover routing policy, right? So what is failover routing policy, right? Failover routing policy is used for failover. As the name says, it is used for failover. Sorry, failover routing policy is used for failover. So same stuff we have. We have our USA ELB, we have our India ELB, right? We have Route 53 which handles our DNS records. We have requests which are coming in for our domain, right? So now what is failover routing policy is you are going to assign one resource as the primary, one as the secondary. So this failover routing policy is like active passive failover. It is not active active, it is active passive failover. Remember that. Okay, so you assign one resource as primary, one as the secondary. That is up to you, right? So I can say US is the primary, India is the secondary. So when you configure it like this, same thing in your DNS records, you are going to add, you are going to say technoblog.com is pointing to USA, technoblog.com is pointing to India, and USA is primary, India is secondary. So whatever is the primary, all traffic will go there. Okay, all the traffic will go to the primary. Secondary is simply on standby, it is waiting, right? So here also we have ELB, we have instance, right? It is there. So if the primary goes down, then all traffic will be routed to the secondary automatically. Once the primary comes back up, then again all the traffic is routed back into the, once the primary comes back up, all the traffic will be routed back to the primary. This is called the failover routing policy. It is active passive. Okay, so we will see how to do this. So in order to do this, you need to use health check. It is compulsory, right? So health check is another service on AWS which we'll talk about, right? So how does it know that primary is up or down, right? For the other routing policies, health check was not compulsory, but there also you can introduce health check. Health check is what? It is just going to check the health of that resource, right? If it is okay, it will send the traffic, otherwise it will not send, right? For this failover routing policy, you have to use a health check. Health check is compulsory, right? So you have to health check at least the primary. Secondary is optional, right? So based on this health check, if this health check is going to pass or fail, if the health check is going to pass, then all your traffic will go to the primary. If the health check fails, then traffic will not go to the primary, it will go to the secondary. Again, once the health check it passes, it will stop sending to secondary, it will again start sending back to the primary. This is how the failover routing policy works. It is active passive. That is, the secondary is simply waiting for the primary to fail, right? It is parallelly not handling traffic, right? So in order to do the failover policy, same thing, you're going to create two record sets. One you're going to assign as primary, one as secondary. One additional step that you need to do is you need to configure something called a health check, at least on the primary, right? So what is this health check? Right, so in route 53 itself, right, if you look on the left here, you will have something called health checks, right? So it is not like ELB health check, right? So it is also somewhat similar, but it is not same, right? So it is a service which is offered through route 53, which lets you, what do you say, uh, do a health check on anything. It does not have to be a AWS server or a resource. You can health check anything, right? So you might have used some third-party tools in the past, right? Like services like Pingdom, right, or some third-party monitoring tools which monitor your internet connection at office, or some servers or something like that, right? So Route 53 Health Check is also something like that, right? So it is a service which lets you do a health check on your servers or endpoints or the network, right? So you can monitor a domain, you can monitor an IP address, right? So you can say create health check, and you can give it a name, some name. Say for example, you have some internet connection at office. So how do you know whether the internet connection is up or down? So if you have some service inside your office, right, and if your internet connection is down, you will not get an alert, right? So probably you want to check it from outside, right? So how do you check whether your phone at home is working or no, landline? You will call from somewhere else outside and see whether incoming is working, right? So same thing here, you want to check from someplace outside. So Route 53 has a service called health check, from where you can check the health of different, what do you say, servers or IPs or whatever, right? It can be anything, it can be on premise, it can be Azure, it can be anything, right? So now say for example, you have some server hosted in your office, let us say my application, right? So you can say, right, monitor an endpoint. What is our endpoint? Is it an IP or a domain? Say you have an application hosted somewhere, you want to know whether your application is up or down. So you can create, like for example, I want to check google.com, right? You can specify the path, the port, and all that stuff. You can go to advanced configuration, you can specify how frequently to check, what is the failure threshold, right? So the default is standard, so it checks every 30 seconds, right? It is going to like ping Google and check, right? If it fails 3 times continuously, it will say Google is down, right? And all these are additional stuff, but you don't need to go through all these things. But basically, what is health check, right? It lets you check the health of some endpoint. It can be a domain, it can be an IP, basically. And you have additional features. So basically, AWS will try to check google.com from all these locations. It does not check from a single location. AWS checks from all these locations, right? So it will ping, like it will check Google from all these 7 or 8 locations, right? And when I say create health check, right? So if you want, you can create a notification, right? So whenever it fails, you can get a notification. We'll talk about this when we come to SNS, right? You can create an alarm and you can get a notification, like your billing alert, right? So whenever the health check fails, you will get an alert, right? If you don't want alert, you don't need to create alert, right? It will simply say health check failed. So currently the status is unknown because we just created it. It will take a minute or so for this to turn healthy. So if you go to health checkers, here you will see that it will start checking Google, right? Here you see it will check Google from all these locations. And what is the status code it is getting? 301, because it probably goes to HTTPS, right? It goes to some other thing, right? Okay, so like this you can check the health of pretty much anything. It can be your own server or some website you want to monitor, or your website you want to monitor, or your internet connectivity at office you want to monitor, the public IP you want to ping the router. You can do all that. Now you see it's saying Google is healthy because it's passing all the health checks, right? So if Google goes down, it will say it is unhealthy, right? So like this you can check the health of a lot of stuff. You can say create health check. Suppose you want to monitor your internet connectivity at office. So usually they will have a static IP, right, on the router. So you can ping a TCP, you can give the IP address, you can specify the port on the router that you want to ping, right? And you can do some advanced configuration if you want, right? And if your internet connection is down, the ping is going to fail at the router, right? So you can know that your internet connectivity is down at office, right? So like that, it can be a server IP, it can be your internet connection IP, it can be a domain name, pretty much anything you can do a health check on. It does not have to be inside AWS, it can be anywhere, right? You can check your application servers, mail servers, ISP connections, all these things, right? To basically get an alert whenever there is an outage, right? So AWS provides that service under Route 53 health check. This is different from ELB health check, right? So it is not performed by the ELB. This is performed by Route 53. So using Route 53, you can check the health of your ELB also, which is what we are going to do now, right? So now what are we going to do is, right? So we have this infrastructure already, right? We have created our USA, we have created our India. So now what I'm going to do is I'm going to say my USA is the primary and India is the secondary. Okay, so we will create this thing. So now what we need to do is we need to create a health check on USA. On primary it is compulsory, otherwise failover routing policy will not work. It needs a health check. Okay, so first what I'm going to do is I'm going to create a health check for my primary. That is, I'm going to do the health check on my ELB, right? I'm going to do health check on ELB. ELB will do the health check on the instance, right? So what I am checking is whether my ELB is responding or no, right? Because we point to the ELB. So I'm going to check whether my ELB is up or down. I'm going to check the USA ELB. So we will go here, right? I'm going to say create health check, right? I'm going to say my USA ELB, right? So all these are advanced, right? So you can do based on the status of another health check or based on the status of a CloudWatch alarm, right? You can do advanced things. This comes in advanced networking. So we'll not go so much in depth. If you're interested more in monitoring type kind of thing, then you can go in detail about this, right? So we are monitoring an endpoint, either an IP address or a domain name. And remember, now our ELB does not have an IP, so we use domain name, right? So what is the domain name? You take your USA ELB's domain name, right? So I am asking Route 53 to hit my ELB and see whether it is getting a response, right? You can specify the path if you want, or it will ping the default path, right? Just the thing, right? And you can give advanced configuration if you want faster interval. You can give faster interval. These are advanced features. If you change anything over here, you pay an extra fee, right? The health check type is basic, no additional options selected. So you get, I think, a couple of health checks free in the free tier. But if you use any of the advanced options, that you change any of these options, it will cost you little more. Okay, So I'm going to make it fast so that we can see it quickly, right? And I'm going to say failure threshold is 2. So if it fails 2 consecutive health checks, then it will mark it as unhealthy, right? So here it says basic plus additional options, and I'm going to say next, and I don't want an alert. I just want a health check to be created. So what is this health check? It is going to check this domain name. It is going to hit this URL, right, from different locations. So it does not check from one single location. It checks from 8 different locations, right? It's not a one-time check. It continuously keeps happening, right, depending upon the interval that you specify, right? Every 30 seconds or every 10 seconds, it is going to ping from 8 different locations, right? And it is going to see whether it is going to pass or fail. So if it is going to pass, the status will be healthy. So now it is saying the US ELB is healthy, right? Because we have our instance behind it, it is working. Our instances are healthy. So, and our ELB also is not having any problem. So indirectly it is healthy, right? So route 53 is saying the USA ELB is healthy, right? It's reporting it as healthy. So it still continues performing the checks. It is not that once it is healthy, it stops. No, it continuously performs the health checks, right? You see, it is continuously performing the health checks in the interval that you specified, right? It continuously keeps performing these health checks, okay? And it is saying it is healthy. Now we will go to the DNS records, right? You go to hosted zones and you go to this thing, right? So we have created the health check on the primary, right? We have created the health check on the primary. Now we will go and we will add these DNS records, okay? So here again same thing, you go to record set, right, alias, right? Here you choose, say for example we said USA is the primary, right? So we will choose USA and here we'll say failover. So when you do that, right, so you have to specify whether this is primary or secondary. So we have decided that we will keep USA as the primary. That is up to you, okay? I'm saying USA is the primary, right? And I'm going to say associate with health check. So we have created a health check, right? It will show up over here, right? It will show up over here. So I'm saying create, okay? Same thing, I'm going to create another record set, right? I'm going to point it to India and I'm going to call this failover and I'm going to call India as second. If you want, you can give it a health check. It is not required, right? Because automatically if the primary it passes, it will reroute the traffic, okay? So here I'm saying technoblog.com, right? Pointing to US is the primary, pointing to India is the secondary, okay? And we have a health check configured on the primary, right? So as long as the primary is healthy, all traffic will go to the primary, okay? So now we'll open the website. Now it should go to US, right? Because it is the primary, right? You see traffic is going to US, right? Any number of times you refresh, as long as the US location is healthy, traffic will go to the US, right? India is there. It is just as a standby, active passive failover this is, right? So now if there is a problem with the US location, right? So say for example I go and create some problem. So how can I create a problem? Say for example I'm going to stop this instance, right? Say I'm going to create a problem. I'm going to stop this instance, right? So now what will happen? So if you come to route 53 over here, right, and you go to the health checks, why is this not opening a new tab? Okay, If you go to health checks, here you will see this health check will change to unhealthy. It will not instantly change to unhealthy because it is going to take some time for it to identify, right? It has to fail 2 consecutive health checks. So here you will see, in a minute or so, you will you will start to see that it is going to fail, right? Here, because the ELB has to first identify that the instance is down. First of all, I hope no, I didn't stop it. Something happened. Okay, so let us go and say stop again. Probably because I connected to the VPN, it had to refresh. Okay, right. So now I am stopping my instance, right? So I'm creating some problem. So if you come back to the health check, here you will see it is going to start failing. Right here you see it says failure, success in between. So it needs 2 consecutive failures ideally, right? So then it will say unhealthy. It will take a minute or so for this to show up, right? Your ELB will automatically do its own health check and say out of service. So when your ELB says out of service and something else is checking the ELB, obviously it is going to fail the health check. So it will say unhealthy, right? So again, it will take a minute or two for it to say. So don't just think that here just you saw 2 failures. Why is it not showing? It will take some time. So it is for every time it checks, it pings 8 times. Each check is like 8 pings or something like that, right? So now here you see it's saying service unavailable, right? Because we don't have any instance in the ELB. Backend server is at capacity or something. Here we don't have any capacity, right? So now here you should see it become unhealthy any second now, right? So maybe in between the users might get an error, right? Again, this is coming from the cache, right? Right now you see it will come from India, right? Because probably this has already become unhealthy, right? Yeah. Now you see it has become unhealthy. So now all traffic will go to India, right? I didn't change anything. I just created a problem, right? I stopped the instance. So now all traffic will go to India, right? Now if I fix this problem, say I bring this instance back up, what will happen? In a few minutes, the load balancer will say the instance is in service. Then the health check, which is checking the load balancer, will say healthy. So once this uh, turns healthy, your traffic will automatically go back to US, right? Until then, it will be served from the secondary. Once the primary again it passes its health check, then it will go back to that. Okay, so again you just have to wait for a couple of minutes. So remember, this is active passive, it is not active active. So there will be a couple of minutes of downtime depending upon how you configure the health check, how long it takes to respond and identify the failure, right? So we have started the instance, right? So the load balancer health check, it has to pass first, right? So it has passed the load balancer health check. Now it has to pass the route 53 health check, right? So it has to pass, I think, 2 consecutive route 53 health checks, right? Now you see it started passing. So again, in a few seconds, you will see that the status is going to become healthy. Okay, so it's just going to take a couple of minutes. Not couple of minutes, probably a few seconds, because we put a fast interval, right? So yeah. So let me meanwhile refresh this page. Right now you see it is back to US because the US is up, right? It is healthy now. So here it might take a few more seconds to show up, but here you see it has already failed over. Don't worry about this health check. So this console sometimes might be a little laggy, but here you see it has gone back to the US server because it is up, right? Now it is serving from the primary, right? Here it will say eventually it will show up as healthy, right? So don't worry about this. This is probably, it's related to the console. It is slightly laggy. Probably in the new console it might be better, right? Here you see it's passing the health checks, right? So it said the US one is healthy. Okay, so here it is misleading, but yeah, it has already failed over back to the primary, right? So this is called the failover routing policy. Okay, so let me know if you have any questions so far over here.
No, Siddharth.
Okay, so here you just have to know the basic routing policies. These are the basic routing policies. So you have another routing policy over here called multi-value answer. Okay, so now you see it's reporting as healthy, right? It just took a little more time for the console to reflect it. Okay, so let me clean this up. Let me delete this health check, right? Let us go back to route 53 and delete our hosted zones. Okay, so here you have another routing policy called multi-value answer, right? So what is this multi-value answer is? It is similar to simple, right? Multi-value answer is similar to simple routing policy, but as the name says, you can have multiple values. Even for simple, you can have multiple values. Here itself, you can put multiple IPs, right? For simple, here itself, say for a record, you can put multiple values, right? So what happens with simple? What is the main differences with simple is, right? Simple also, it can have multiple values, but all DNS providers might not allow you to put multiple values, right? So in the simple routing policy, what happens? Suppose you put multiple values for your record, right? You're saying technoblog.com, right? In one record itself, you're putting multiple values. It's not two different records, remember, right? For one record, you're putting two different values, something like this. You can do that, right? Technoblog.com. This is one single record. It has two values, right? And the routing policy is simple. It is not multi-value, but we have multiple values. If you go to multiple value also, it is the same thing, right? But the difference here is with multiple value answer, you can associate it with a health check. Whereas simple routing policy, you even though you can give multiple values, you cannot associate a health check with a simple routing policy, right? So what will happen when you give multiple values like this is route 53 will randomly give some answer, right? You can have multiple values for the same record. This is one record, right? So it will randomly give. So whenever a request is coming, sometimes it will give 1.1.1, sometimes it will return 2.2.2, right? It is a very crude way of achieving some high availability of, right? So here you cannot do any health check, whereas with multiple value you can do health check, right? So with uh, multiple value routing policy, same thing, you can give multiple values, but you can associate a health check with these things, right? So if the health check fails, it will not give this, it will give these two, right? So not many people use multiple value, mostly they use the other things, right? So but it is also a simpler way of doing certain things, right? So that's the main difference between simple and multiple value, right? So with multiple value, if you want, you can attach a health check. It is not compulsory, but it is possible. If you don't attach a health check, again it is just going to randomly uh, give any one of this answer, right? So what is route 53? Basically it is answering DNS queries. So somebody is saying I want to go to technoblog.com, route 53 will give the answer. What answer will it give depends upon the records which you have added in the routing policy, right? So many people think simple means you can add just one value. No, in simple also you can add multiple values, but the main difference being how it is. I mean, this additional health check thing, right? So that is what is multi-value answer, right? So these are the routing policies that you need to be aware of. Okay, and here you have,
Sure. So,
yeah, go ahead.
yeah. So my manager is calling me in call. Just I'll be in mute. Okay.
Okay, okay, yeah,
Yeah.
okay. So these are the main routing policies that you have to be aware of. Okay, all right. So what else do we have over here? Yeah. So here the next thing is we have something called traffic flow, right? Again, traffic flow is for advanced what do you say? Advanced networking, right? So we'll just probably see like maybe high level what is traffic flow, because traffic flow is very it's a very expensive service, right? So traffic flow, right? It is basically something that allows you to visualize your traffic and create sophisticated routing configurations, right? So this comes in advanced networking, right? So basically you can draw a flowchart, right, for advanced DNS routing. So what we saw was most common stuff, but if you want to do it advanced, so some request is coming, it is going here, right? Then from here, based on failover, it is going somewhere. Then based on weight, it is going somewhere. So you might have had that doubt while I was creating. What will happen if I mix and match? Some of them will give you error, because if you don't know DNS properly and you put you mix multiple types, sometimes it will not let you create, right? Sometimes it will give you error, right? Certain things, for example, now if I go and point to this, right, it will give error, right? It's saying it is already existing. So you can say what will happen if I give both a record and alias. Sometimes it will not allow, it will give you an error, right? So we have different routing policies. What happens if you mix and match? You will get error, right? Which is why I removed the records and then again created fresh, right? So if you do like that, it is going to give you errors. But if you want to do some advanced routing policies, right? So a request is coming, based on that you want to go somewhere, based on the failover, then again you want to do some uh, weighted routing policy, right? Then you go somewhere, right? So you can create that flow chart over here in traffic flow, right? So each flow, each traffic flow, that is, you create a traffic policy. Each policy is $50. So we are not going to create that. Okay. So, but you should know what this is, right? So it gives you a visual editor, right, to create complex configurations and save them as a policy, right? So it is going to tell where the traffic has to go based on what condition. If some condition is matching, do something else, those type of things, right? So traffic flow, in traffic flow you have a traffic flow policy, right? You can give your policy some name, right? Here you can have different versions. This is an advantage, right? So it is basically like the Google Maps, right? So think of something. What is Route 53? It is basically answering DNS queries. So you can say if a request is coming, you you go to something based on it is failover routing policy. Then you have a weighted routing policy, right? Then you go to USA, you go to India. This is the primary. Secondary, you have something else, right? It goes somewhere else, right? So you can specify these things, right? And advantages, you have something called the versioning. So you can call this traffic flow or traffic policy one, right? Suppose you want to update something, right? So you can update this traffic policy. You can maybe change this to Singapore, and you can save it as what do you say? This is version one. Then you can save it as version two. If version two is having a problem, then you can revert back to version 1. Basically how you want the traffic to flow. Like remember on important Independence Day or something, they will have a different traffic flow, right? They will block certain paths, right? So basically something like that, right? So you want to do some advanced DNS routing, advanced DNS configuration, right? For that you can use the traffic flow, which is like a visual flow chart, which lets you uh, which makes your work easier, right? So you can call this version 1 because it's the first version, and then you can use this flow chart, right? An A record, it connects to one of these things, right? All these are your existing, what do you say, routing policies, with the exception being geo proximity, right? We'll again just see what is geo proximity in a high level. Geo proximity is also a routing policy, but it can be done only through traffic flow, right? The other things can be managed through the regular thing, but the geo proximity, right? Geolocation is different, geo proximity is different. Okay, latency, geolocation, geo proximity, they are all different things, right? Geo proximity is somewhat similar to geolocation, but it is more accurate, right? So these are all your existing routing policies, right? So you can give a weight, you can specify the value, right? And you can say connect to your ELB, right? uh, you can add the value, right? You can add your ELB's DNS name here, right? You can give it another weight. So basically whatever we are doing, right, you can do that like this, right? You can say based on some condition do something, right? Or in between you want to add another weighted rule, right? So you can create advanced uh, DNS routing using traffic policy, right? That is what basically is traffic policy. It lets you create complex configurations and save them as policies, right? So each traffic policy costs $50. It is not there in free tier, right? And this comes in advanced networking. For the associate and the ops, you don't need to know so much, but you should know what is traffic flow or traffic policy, right? uh, One more important thing here with traffic policies, like here when we have our uh, the standard, I should not say standard, the common routing policies, right? You have these routing policies, these 6 routing policies: simple, weighted, latency. We saw these 6, right? There is another routing policy called geo proximity. So geo proximity also comes in advanced networking, but geo proximity you cannot do from here. If you want to use geo proximity routing, you have to use traffic policies, right? Geo proximity is possible only through traffic policies and is also advanced. So here you have geo proximity. So what is geo proximity is, you can narrow down the coordinates of where the request is coming from, right? So earlier we saw like India, we saw USA, we saw a state. Now with geo proximity, what you can do is you can narrow down that location. I can even put an area, right? You can see the map over here, right? It shows you the map, or you can enter the latitude and longitude coordinates. So for example, say I'm in Hyderabad, right? So I can say if traffic is coming from Hyderabad, you send somewhere, right? So it is very specific, or inside Hyderabad some area. So say for example I pick Hyderabad, say latitude and longitude, right? You can pick it up from here, right? So I can take this, I can put that over here, right? What is the latitude is, this first one is, right? The longitude is going to be this, right? Now here you see it is showing me that on the map, right? So I can narrow down the location. The region is this, right? So inside India I can narrow down to a small area also, right? You see it is pointing to Hyderabad, not entire AP or Telangana or India, just Hyderabad, right? So you can narrow down the locations, right? So this is called geo proximity, right? So you can add multiple locations. It is called, you have something called a bias, right? So this is in geo proximity, right? So you can actually drill down to the granular location in geo proximity, and you can assign some like weight. It is called a bias, right? So let us just open this, just high level, if you know it is enough, right? Geo proximity routing policy, right? Right. What is geo proximity, right? So geo proximity, it lets you route traffic to resources based on the geographic location of your users and the resources, right? So you can choose to route how much traffic to a specific resource based on a bias. It is like weight, right? Something like weight. So you can shrink or increase the geographic region from which the traffic is routed to the resource, right? To use geo proximity routing, you have to use traffic flow. You cannot do it, what do you say, you cannot use the standard route 53 console, right? So like this, you can say so much traffic has to go from here to here, from here to here, like that mapping, right? So I just added one single location, but you can add multiple locations, right? So you can specify that, right? You can specify, you can drag and drop in the map, or you can specify the latitude and uh, longitude, right? So this is advanced routing, but you can split up even more in detail than just using your standard geolocation. You want more granular control, and you want to send only so much traffic to a particular region. You can control all that using geo proximity routing policy, right? So you can increase or shrink this, what do you say, the size and the bias, right? So how much traffic where you want to send, right? So all this comes in advanced networking, the networking specialty exam. But you just have to know that geo proximity is also possible, but it is possible only through the traffic flow or traffic policies. You cannot create it normally, okay? These other things, you can use the standard route 53 DNS record sets to use, and you can also use it through traffic flow if you want to, right? You want to create advanced routing, you can do that also, right? But geo proximity is possible only through this thing, okay? So here you can give a bias between minus 99 to plus 99, right? So, right, so you can choose your location from here also, right? Any of the locations, right? uh, right, you can give it a bias. You can look in the map, right? It will show you the region, right? You can click on this, it will show you the map, right? If you say Ireland, you see this thing, right? So you can increase or decrease this bias, right? Accordingly, like you can add multiple things, all that stuff, right? So here all traffic is going something to Ireland. So here you can add like another region. Say for example, I add Ohio. Maybe now the map will be clearer, right? So here you will see this, right? Like this, right? So you can, what do you say, control which traffic has to go where more precisely using this thing, right? Say if I bring this down, right? Let us make this something like this, right? So like this, you can split up the world. So maybe if I zoom out, it will be clearer, right? So you can control which part of the world where the traffic goes, how much the traffic goes using this geo proximity routing policy, right? So these are the things that you need to know with respect to Route 53, right? What are the different routing policies and where is it going to work? Okay, so please let me know if you have any questions over here now.
No, Sid.
Okay, all right, let me see if I have skipped anything in Route 53. Yeah, okay. So we were talking about the domains, right? So we saw about the public hosted zone, right? So same thing, you can create private hosted zone. So what is a private hosted zone? What is a public hosted zone? Private hosted zone is like your local DNS in AWS, right? So for example, in your company, right? Suppose you're connecting to some server. How do you connect to it, right? Say you have a application server, right? You have a DB server, right? So I think you guys are developers or with a database background, right?
Yes, Sid.
So how do you connect to the DB server, right? They give you some URL, right? Some host name,
Yes.
right? Like Microsoft SQL Server hyphen prod dot whatever dot your domain name, say IBM dot com, something like this, right? So you connect to the DB server using its host name or DNS name, right? But this may not be accessible from outside. Maybe it is only internal. If you come home and you put this, it will not connect until you connect to the office VPN or something, right? So this is like a local domain, internal, right? So you can use Route 53 for internal DNS. So inside the VPC, you want to use your domain names to connect instead of the IPs. Again, a lot of people use this, right? So whenever you create a EC2 instance, you will see that you get a default DNS name, right? You get a default DNS. The domain is ec2.internal. This is default. You can rename this to whatever you want. You can rename this to whatever you want in your VPC, right? You can give your own company's name, domain name. Here you don't have to pay for it because it is internal. It does not work over the internet. It is only within your VPC, right? So here you can go, you can manage your DNS over here for your VPCs, and you have all that stuff, right? So if you're interested in that, you can go over here and you can go to DNS host names is there, right? Sorry, the new console, right? You have DNS resolution, right? So all these things you can modify, right? You can modify all these things, right? You can give your uh, DHCP, sorry, DNS related settings, all this advanced networking, but you can manage these things, right? You can change the domain name, right? And you can use that via Route 53, right? Why this is useful is because your servers, their IPs might change, but if you keep the host name same, then you don't need to change the values. You can map it in your DNS. In Route 53, you can create a local zone. Say for example, IBM.com is local, right? And for your DB server, you can say for example Microsoft SQL Server, right? Hyphen prod, right? Dot IBM dot com is pointing to some local IP, right? Something like this, something in your VPC, right? So tomorrow, if you're replacing this server, so in your application server in the connection string or somewhere, you would have specified this DB server, or people are connecting to this DB server to do development work. So they will use this host name. They will be pointed to this server. The server will have an IP, obviously, right? Local IP. So it will be pointed to this. So tomorrow, if your server's IP is going to change, then all you need to do is you need to go into the DNS and update this IP to the new IP. The users and your applications, they don't need to do anything because you have added this name. This name remains constant for this server, for your production Microsoft SQL server. Its IP can change. If the IP changes, all you need to do is go in the DNS, your DNS provider or the network administrator, he needs to update this DNS. Either they have your own local DNS server, or you can use Route 53 also as your local DNS server. It is called private hosted zone. Right? Private hosted zone, it determines how traffic is routed within your VPC. Public hosted zone is traffic flow over the internet. That is for the public domains. So inside your VPC, you can also use the same thing. Right? You can create here, you don't have to pay money for it. Right? Here you can put whatever you want because this traffic will never leave your VPC. It is just inside your network. Right? Your company's name or whatever you can put. Right? And you create it. Right? Sorry. Here you specify the VPC. Right? Whatever the region that you're using. Right? Say for example, we are using US East. Right? So if you're more interested in this type of DNS thing, all this comes in advanced networking. But yeah, so same thing, right? All this is inside. This is a private hosted zone. This is not public, right? So the records inside this will only work inside this VPC that you specify, right? It will work only inside this VPC that you specify. Okay, so here you can create a record set, right? And you can give the same thing. All these things also work, but this is only within your VPC. It is not for IPs outside. You put any IP outside, it will not work, right? Because this is a local DNS, right? That is private DNS. So Route 53 can be used for both. If you want to manage your private DNS, right, inside VPC, you can use this, right? So in order to do this, you have to make sure in your VPC you have enabled both these options, right? Make sure you have enabled both these options, right? Because when you create your own VPC, some of these options are not enabled. In the default VPC, they are enabled, right? But if you are creating your own VPC, right, then you want to use private hosted zones, then you have to make sure that you have your DNS resolution and DNS hostname enabled, right? Like I showed you here, you have this DNS hostname and DNS resolution. You want to make sure that these are enabled. If these are not enabled, then again it will cause a problem, right? Right. Okay. So with this, I think we can complete Route 53. So please let me know if you have any questions over here.
Not sure. Let me check after. I'll go through this. And if I have any question, I will text
Yeah.
you.
So this is
Sure.
all mostly practical, but what you need to know from exam point of view is what are those routing policies and what is the use case for each of those things, right? Active, passive failover, weighted routing policy, right? You'll get, like, people will say you want to send some amount of traffic here, some amount of traffic there, right? Then what policy to use, right? You want to route traffic based on the user's location, right? So those type of questions you will get, but how you do it is what we just saw practical, right?
Yes. Yeah.
Okay. So with this, we will complete the class for today, right? So we'll catch up in the next week. So meanwhile, please go through those questions, right? If you are planning to take up the exam, right? And if you have any doubts, please let me know, right? Yeah. And one more thing before we complete about the cost, right? Very important with respect to Route 53, right? For what do they charge you? I told you for domain, you have to pay for it. If you want a public domain, you pay for it. right? Apart from that, what do you pay for? You pay for the hosted zone, right? You pay for the domain anyway, right? The domain, if you buy, you have to pay for it. Apart from that, you pay for the hosted zone. Hosted zone is what? Each of this that you create, right? So each hosted zone is 50 cents per month, right? It starts with 50 cents per hosted zone per month for the first 25 hosted zone, then so much for the remaining hosted zone. So you pay for the hosted zone, plus you also pay for DNS queries. What is DNS query? If I say ping technoblog.com, it's a query. If somebody opens the website, they are making a DNS query. So you pay for the queries also. So if somebody opens your URL, they are making a DNS query. So you pay for that. But if you use an alias, you don't pay for the queries. That is another advantage of alias, right? If you are having AWS resources, right? Like I said, if you have this technoblog.com, if you are using a load balancer, right? Instead of saying, say for example, you have your URL called demo.technoblog.com, right? You can also map it to a CNAME. You can say CNAME and you can put your, say your load balancer. Say you can put your India load balancer, right? I can say CNAME and put my India load balancer because it's a subdomain, right? So now demo.technoblog.com is pointing to my India load balancer, right? So now if I go here and go to demo.technoblog.com, right, it will come to the India, right? It is working. But here what happens is you will be charged for the DNS queries. That is, every time somebody opens this website, it's a DNS query. You pay for that, right? So if you want to avoid those charges, that is for stuff that you host in AWS, you can use alias, right? So when you use an alias, right, you are not charged for the DNS queries. That is another advantage, right? So if you map it like this, both go to the same thing, right? Both point to the same thing, but how you do it is different, right? Now still it will open the same website, but now it is working through AWS's feature called alias, right? So when you use alias, and remember alias is always some other AWS resource. It can't be whatever you want. It is one of these things in AWS. So if you have your stuff in AWS, like a S3 website endpoint, CloudFront endpoint, load balancers, you can point to them and they will not charge you for the DNS queries. Otherwise, you are charged for DNS queries. How much you are charged? It's a small fee, but still you are charged. You are charged 40 cents per million queries for the first billion queries, then 20 cents per million queries, depending upon what type of routing policy you are using again, right? So if you are using latency based routing policy, you pay additional fee, right? So they charge you for the domain, for the queries, and for the hosted zones, right? For domain, you pay the domain name. For hosted zone, you pay 50 cents usually, and then for the queries, right? So if you use alias, which are mapped to load balancer, CloudFront, Beanstalk, API, these things, right? There is no additional cost for it, right? If you're using it as an alias, right? So these are the main things, right, that you have to remember with respect to cost, right? Traffic flow, I told you, is 50 per policy per month, right? So each policy that you create is $50 per month, and health checks also, there is a cost, right? We saw health checks, right? Health checks is 50 cents per health check per month, right? If you are using optional features, then you pay $1 per optional feature, right? That is, again, if you are checking endpoints in AWS, you pay this. If you are checking non-AWS endpoints, that is something on Azure or something on your office location, something else, you pay this fee, right? So Route 53, fortunately, it is not there in free tier, right? If you want domain, you have to pay for your domain public routing. private hosted zone, you can do it internally, right? If you know how to manage private DNS, right? And health checks also, I think you get a couple of health checks in the free tier, right? So let us just go to free tier and just check, right? So here, if you go and search for route 53, it's not there or what? They've removed it or what? I think health checks, there used to be, yeah, seems to have been removed. Let us put in Google and see. Let's go back here and search for, it seems to have been removed. Right, it used to be there in free tier. I think a couple of health checks, I'm not sure. I think they seem to have removed it now. Okay, so yeah, so just be aware of that. Now it looks like there is no free tier for health checks. Earlier, I remember they used to have a couple of health checks allowed. Okay, so that is about the pricing, right? If you're interested in pricing, that is the pricing. Okay, so if you want to practice this, you need a domain. Otherwise, you can just watch this video and you can just you read the FAQs about Route 53. What are the routing policies, right? You basically need to know the first four, right? First 4 or 5 health checks, DNS failover, and if you're interested in private DNS, you can use that also, right? Right. So we'll catch up in the next class. So after you finish practicing this, right? So in case you are using anything, you can leave the hosted zone because anyway you pay for the month once you create it. So if you have your domain, you can just leave the hosted zone because once you create it, you pay for it whether you keep it or you remove it, right? Right. So I'm just going to keep that thing route 53. Right. So make sure you remove any health checks that you have and whatever the load balancers and instances that you created, please delete them. Right. Otherwise, it's going to cost you money. Right. So with this, I'll complete the class for today. We'll catch up next week. Right. So meanwhile, if you have any questions, just let
Sure.
me know. You can. Okay.
Sure. Thank you.